Everyone. In this video I will be going over the elimination method for solving systems of linear equations. So if we take a look at our learning target, I can solve a system of two linear equations using the elimination method. Our vocabulary for today will be coefficient, elimination method, and scale. So to solve a system of linear equations using the elimination method, our goal is to eliminate one of our variables by combining our two equations. In order to eliminate a variable, we must first pick which variable we want to eliminate. So we'd be looking at our letters, most often x and y. Once we do that, we have to make sure our coefficients are the same number with opposite signs. From there, we can combine, solve for one variable, then substitute what that variable is equal to into one of our original equations to solve for the other variable. Let's first check out an example in case any of that was a little bit confusing and you're not quite sure what I'm talking about. So if I have this system right here, negative x plus 3y equals negative 2, and 4x minus 3y equals negative 10, I need to pick a variable to eliminate. So I can either eliminate my x or I can eliminate my y. It will be in our best interest to choose a variable where our coefficients are the same number but have different signs, if possible. For some examples, this will not be possible right off the bat. So taking a look at this example, what variable has the same coefficient with different signs? Okay, if I take a look at my x's, my top x has a coefficient of negative 1, my bottom x has a coefficient of 4. If I take a look at my y's, my top equation, or my top y, has a coefficient of positive 3, my bottom equation has a coefficient of negative 3. Okay, y would be our best candidate here to eliminate. So what variable has the same coefficient with different signs? Y has coefficients of positive 3 and negative 3. Because this condition is satisfied, we may combine our equations and proceed with the elimination process. So I will change my color here. So taking a look at my first step, I still have the same example problem. I'm going to combine the two equations, eliminating the y. So what I like to do is I like to put a line underneath. Now I'm going to combine my top equation with my bottom equation. So taking a look at my x's, I've got negative 1x and a positive 4x down bottom. So this will be negative 1x plus 4x, which will leave me with 3x. 3y minus 3y cancels, or it eliminates. That's why we call it the elimination method. That is a desired result right there. Equals negative 2 and a negative 10. Okay? Because this 10 is negative down here, the operation depends on the sign of the bottom number. So because it is negative, I will do negative 2 minus 10, which is negative 12. From here, I can solve for x because I only have one variable. So I've got 3x equals negative 12. To get the x by itself, I can divide both sides by 3. When I do that, those 3's are going to cancel. I'm left with x equals negative 12 divided by 3, which is going to be negative 4. Since we now know what x is, we need to find y. So the way we're going to do that is we are going to pick one of the original equations, and it doesn't matter which one, we should get the same answer, and plug the x value in for y, or plug in the x value for x to solve for y rather. So if I go back up to my original equations here, I have to pick one of these. Previously, x was unknown, that's why we had an x here. Now that we know what x is, it's the number -4, we can take -4 and substitute it in for x in one of these two equations. Okay, so I'm going to do the bottom one. And the bottom equation is 4x minus 3y equals -10. Okay, so if I rewrite this, I've got 4, instead of x, I've got -4 in parentheses, because I now know what it is, minus 3y equals -10. So I'll continue to simplify this. So 4 times -4 is going to be -16. And then I'll bring down everything else. I'll now add 16 to both sides. When I do that, 16s cancel on the left, so I'm left with -3y equals -10 plus 16, which is going to be a +6. I'll divide both sides by -3. -3's will cancel on the left, and I'm left with y equals 6 divided by -3, which is going to be -2. So I've solved for x, I've solved for y, so the solution to this system of equations, or where these two lines would cross if they were graphed, is the point -4, -2. -4, of course, being the x-coordinate, -2 being the y-coordinate. Okay, so I've got my Bitmoji here. He is saying we won't always be able to eliminate a variable as easily as we did in this problem. We may have to scale one or both of our equations. Here's an example where we may have to scale an equation before we combine the two equations. Okay, so if we take a look at our new system, our new example problem, we've got 5x minus 2y equals 0, and x plus 4y equals 22. In this system of equations, there's no variable where the coefficients are the same number with different signs. So if I decided to choose my x here, I've got 5 and 1 as my coefficients. Those aren't going to eliminate each other. And for our y's, we've got -2 and +4. Those aren't going to eliminate each other either. Okay? So that means we're going to have to scale one of our equations. Okay? Looking at this system, let's choose to eliminate y. Okay? To do this, I need -2y to be -4y. If this were -4y, it would eliminate because I would have -4y plus 4y, which is 0. It cancels out. So what can I multiply -2y by to get to -4? We can multiply by 2. Okay, -2y times 2 is going to be -4y. If I scroll down a little bit, As we just said, we are going to scale the top equation by a factor of 2. So in order to change this negative 2y without changing the entire equation or the entire makeup of the equation, I need to multiply the entire equation by 2, okay? So if I rewrite these over here, I will distribute this 2 to everything inside the parentheses. I will have 10x minus 4y equals 0. Just multiplied that 2 by everything. And then I'm not changing this bottom equation, so I'm just going to rewrite it over here. Okay, so we need to combine these two equations. This is awfully similar to our first example where we have something that automatically eliminates now. So let me rewrite these. So I've got 10x minus 4y equals 0, and x plus 4y equals 22. I'll draw a line underneath. Negative 4y plus 4y is going to cancel. 10x plus 1x is going to be 11x. 0 and 22 is 0 plus 22. So I just get 22. From here, I will scroll down and solve for x. So I have 11x equals 22. So obviously to solve for this, I need to divide both sides by 11. 11s are going to cancel. So I get x equals 22 divided by 11, which is 2. So since we now know what x is, we need to find y. So let's go back up and pick one of our original equations, and it doesn't matter which one, and plug the x value in for x to solve for y. So if I scroll all the way up here, okay, I've got 5x minus 2y equals 0. Let's use that one. I could also use the x plus 4y equals 22. In fact, that would be a good exercise to check your answer, is to plug it into the top equation and the bottom equation and see if you get the same number. So we'll do 5x minus 2y equals 0. Okay, I'm going to plug in 2 for x. Five times two is going to be 10. I can subtract 10 on both sides. Ten minus 10 will cancel, so I get negative 2y equals negative 10. Last step, I can divide both sides by negative 2. When I do that, negative 2's will cancel. So I'll come right up here because I'm running out of space. I get y equals positive 5. Negative 10 divided by negative 2 is going to be positive 5. So the solution to this system of equations is going to be the point 2, 5. So let's take a look at another example. Okay, so we've got negative 3x minus 3y equals 9. And we've got negative 2x minus 7y equals 21. So taking a look at this, let's take a look at our variables first off. So if we take a look at our variables, Specifically, we're going to look at the coefficients and see how much work we're going to have ahead of us. For our x's, we've got a coefficient of -3 and a coefficient of -2. When we combine those, they will not eliminate. They are not, -3 and -2 are not the same number with different signs. If we take a look at the y's, we've got -3 and -7 as our coefficients. Those are also not the same number with opposite signs, so they're not going to eliminate either. So we're going to have some work ahead of us, and that's completely okay. In this system of equations, is it possible to scale only one equation? Okay, and despite what I just said, yes, it is possible. Okay, and it is possible because there is a number that we can multiply -2 by, for example, to get to +3. Okay, but in order to do that, we would be multiplying by a fraction, or we would be scaling by a fraction. So we can scale using a fraction. Oops. Running out of space. Okay, and why would we try to avoid doing that? Okay, why would we try to avoid scaling by a fraction? We would do this because scaling by a fraction makes the problem more difficult. Okay, I'm a math teacher, and even though I love working with fractions, even I'll admit that if I have to scale one of these two equations by a fraction, that's going to be maybe not more difficult, but it's going to be a lot more work than I'm not going to say that I'm willing to put in, but if I can avoid fractions, I would try to avoid fractions. I much rather deal with integers. So what should we do instead? There is a way around this. We should scale both equations. Okay, my Bitmoji down here is saying we can do this by finding the smallest number that our coefficients of x go into, or the smallest number that our coefficients of y go into. And once we have done this, we have to scale both equations to get to that number. Okay, and if that doesn't make much sense, we'll take a look at that right now. Okay, so it really doesn't matter what we do. How about let's try to eliminate x. Okay, so if I try to eliminate x here, if I try to eliminate x, okay, I need to find the smallest number that is divisible by both 3 and 2. Okay, and the smallest number that those two numbers go into is going to be 6. Okay, so how about I multiply, because I need one of these equations, I need one of the coefficients to be +6 and the other to be -6. How about I multiply the top equation by +2, And the bottom equation, I'm going to have to multiply by a negative in order to make it positive. I'll multiply by, or scale by, -3. Okay, so if I do that, distribute 2 to everything in parentheses, and then down bottom distribute -3 to everything in parentheses. 2 times -3x is going to be -6x. 2 times -3y is going to be -6y. And 2 times 9 is going to be 18. For the bottom equation, -3 times -2x is going to be a positive 6x. -3 times -7y is going to be a positive 21y. And -3 times 21 is going to be -63. So I'll scroll down a little bit. Okay, so now I can combine the two equations and eliminate a variable. So I'm just going to rewrite my two equations again. Okay, so -6x plus 6x, that will cancel, it will eliminate. -6y plus 21y is going to be a positive 15y. Okay, and 18 minus 63. So the difference between 63 and 18 is going to be 45. 63 is negative, that's the larger number, so this is going to be -45. So I get 15y equals -45. So I will rewrite that. I'll divide both sides by 15 to solve for my y. 15s will cancel, so I get y equals -45 divided by 15 is going to be a -3. Okay, so since we now know what our y is, we can take this -3 and substitute it in for y in one of our original equations in order to solve for x. So if I go back up to my original equations, you do have 4 options here. Okay, you can use this original top equation or this original top equation. You can use the original bottom equation, or you can use one of the scaled equations, the scaled top or the scaled bottom. Typically though, the scaled top or the scaled bottom, they're going to be dealing with larger numbers than the original problem. So it would be easier on us if we use one of the original equations. So how about we do the top one? So -3x minus 3y equals 9. Okay, so I am going to replace the y this time, because I solved for y instead of x, with -3. So I've got -3x minus 3 times -3 equals 9. -3 times -3 is going to be a positive 9. I'll bring everything else down. I'll subtract 9 on both sides in my quest to isolate my x. 9 minus 9 will cancel, so I'm left with -3x equals 9 minus 9, which is 0. I'll divide both sides by -3. Negative 3 divided by negative 3 cancels. So I'm left with x equals 0 divided by negative 3, which is going to be 0. So the solution to this system of equations is going to be the point 0. Let me switch the color. Let me do that in purple just to be consistent. Here we go. It's going to be 0, negative 3. Okay, so we do have a couple special cases, as we typically do. We know we can always get one solution, no solution, or infinitely many solutions. So let's take a look at what no solution and infinitely many solutions is going to look like. Okay, so if I take a look at my top equation here, or my top system, rather, I have 10x minus 5y equals negative 3, and I've got negative 10x plus 5y equals 10. Okay? So I've got options here. For example, if I take a look at my coefficients of x, I've got a positive 10 and a negative 10. That's what I'm looking for. They are the same number, those coefficients, except they have different signs. So they are going to eliminate. Okay, so 10x minus 10x, that eliminates. But then if I take a look at my y's, negative 5y plus 5y, that's also going to eliminate. So what am I left with on the left side? Left with 0 equals negative 3 plus 10, which is going to be 7, positive 7. Okay, so my goal is to solve for one of my variables once I go through the elimination process. And when I went through the elimination process this time, both my variables canceled. So it's not possible to solve for a variable. So first thing I'm going to do is I'm going to evaluate this. By evaluate, I'm going to check and see if this makes any sense or not. So does 0 equal 7? Okay, equal meaning they're the same number. Well, 0 and 7 are not the same number the last time I checked, so this is false. Okay, so if the final statement, and by the final statement I mean this final equation once you've gone through the elimination process, doesn't make any sense, the solution to the system of equations is no solution. Okay, and it's no solution because these lines will never cross. And when two lines are never going to cross, that means they are parallel. They have the same slope. Okay, almost done here before we head to a bunch of different example problems. Okay, so if I am going to pick a variable to eliminate here, if I take a look at my x's, I've got 8 and negative 8. That's a good sign. My x's will eliminate. But if I take a look at my y's as well, I've got 3 and negative 3. So those are also going to eliminate. Okay, so if I combine these two equations, x's eliminate, y's also eliminate. So on the left side, I have 0. I've got nothing. Equals 29 minus 29, which is going to be 0. So this is my final statement here. I have no variable left to solve for. And 0 equals 0. Okay, this is true. They are the same number. Okay, so if the final statement does make sense, and this does make sense, this is true, 0 does equal 0. The solution to the system of equations is infinitely many solutions. because these lines intersect at every point. By this I mean they are the same line. Okay, let's continue on. We now have our examples. So let me get set up for these. So our first example problem. Let me get a smaller marker here. Okay, taking a look at my first example problem, we've got negative 6x minus 6y equals 18, and we have 7x plus 6y equals negative 12. Okay, so when taking a look at which variable I can eliminate, this is one of those easier ones where I'm not going to have a whole lot of work ahead of me before the elimination process, because if I take a look at my y's here, my top y has a coefficient of negative 6. My bottom y has a coefficient of positive 6, which means negative 6y plus 6y is going to eliminate. So if I combine these two together, negative 6y plus 6y is gone. Negative 6x plus 7x is going to be a positive 1x. And 18 minus 12 is going to be positive 6. Okay, and that's my last step right there, because I have a coefficient of 1 right here, so I don't need to do any division in order to get the x by itself. So what I'm going to do now is I'm going to pick either the top or bottom equation and replace my x with 6. Okay, so how about we do the bottom equation? So I'll do that right over here. So if I do the bottom equation, I've got 7, but instead of x, I've got 6 plus 6y equals negative 12. If I continue to simplify, 7 times 6 is going to be 42. Plus 6y equals negative 12. Bring all the stuff down that I haven't touched yet. I can subtract 42 on both sides. When I do this, 42 minus 42 cancels. So I get 6y equals negative 12 minus 42. So negative 12 minus 42 is going to be a negative 54. I can divide by 6 on both sides to get the y by itself. 6's will eliminate on the left side. So I end up with y equals negative 54 divided by 6, which is going to be negative 9. So the solution to this system of equations is going to be the point 6, negative 9. Move over to number 2. Taking a look at number 2, okay, if I look at my x's, I've got 2x minus 2x. Okay, so my coefficients are the same number with opposite signs, so that's good. Those are going to eliminate. And for my y's, I've also got a 2 and a negative 2. So if I combine these, my x's are going to eliminate. My y's are going to eliminate. So on the left side, I'm left with 0. On the right side, I've got negative 2 plus 0, which is going to be negative 2. So my goal was to solve for a variable. That's not possible here because I've got no variable left. So I will evaluate my final statement here. Okay, and 0 equals -2, that is false. They are not the same number. So because these are false, I'm not going to have a coordinate as my final answer. My final answer is going to be no solution. Okay, that was a quick and easy one. Let's go down to number 3. So taking a look at number 3. Okay, I've got 3x minus 6y equals 15, and I've got 3x minus y equals 0. Okay, some people take a look at our x's right here, and they see the same number. They see 3 and 3, so they think, oh, those immediately eliminate. Okay, these aren't going to eliminate because even though they are the same number, they don't have different signs. Okay, they don't have different signs. So what I need to do is I need to make one of these negative, which means I need to scale either my top or my bottom equation by a -1. Okay, so how about I scale the bottom equation by -1. I'll rewrite my two equations over here. So my top equation isn't going to change. I've got 3x minus 6y equals 15. For my bottom equation, I will distribute -1 to everything inside the parentheses. So I get -3x plus y, sign just changes there, equals 0. So now I can continue on with the elimination process. So 3x minus 3x will eliminate. -6y plus y is going to be a -5y. And 15 plus 0 is going to be 15. So I can divide both sides by -5 to get the y by itself. -5 and -5 will eliminate. So I get y equals 15 divided by -5, which is going to be a -3. So now I can take this -3, I can plug it into either the top or bottom equation and solve for x. So how about we do let's do the bottom equation. So for the bottom equation, I'll have 3x minus -3 equals 0. I've got a -3 here. So if I continue to simplify, I've got 3x plus 3 equals 0. I can subtract 3 on both sides. When I do that, 3 minus 3 will cancel. I get 3x equals 0 minus 3, which is -3. I can divide both sides by 3 to get the x by itself, completely isolated. So x is going to equal -3 divided by 3, which is -1. So the solution to this system of equations is going to be the point -1, -3. Okay, moving on to number 4. About halfway there, I believe there are 8. Yep, 8 problems. So taking a look at number 4. So this one is awfully similar to the last problem we just did. Looks like just about all the coefficients are the exact same. Okay, but instead of multiplying the bottom equation by -1 or scaling the bottom equation by -1, let's try the top one this time. So put parentheses around it, and I'll put my -1 in front. -1 will be distributed to everything. and I will rewrite my new equations over here. So negative 1 times 3x is going to be negative 3x. Negative 1 times negative 6y is going to be a positive 6y. And negative 1 times negative 18 is going to be positive 18. And my bottom one, I'm not scaling by anything, so I will just rewrite it. 3x minus y equals negative 23. I'm prepared to eliminate now, so negative 3x plus 3x will eliminate. 6y minus y is going to be a positive 5y. And 18 minus 23 is going to be negative 5. Divide both sides by 5. 5's cancel on the left, so I'm left with y equals negative 5 divided by 5, which is going to be negative 1. So now I can pick the top or bottom equation, I can plug negative 1 in for y, and solve for my x. Okay, so let's try the top equation this time. Maybe a little bit more work, but when have we ever been afraid of hard work? Never, that's the answer. So, my top equation, I've got 3x minus 6. Instead of y, I've got negative 1 equals negative 18. Negative 6 times negative 1 is going to be a positive 6, so I have 3x plus 6 equals negative 18. I can subtract 6 on both sides. Six minus 6 cancels, so I'm left with 3x equals negative 18 minus 6, which is going to be negative 24. I can divide both sides by 3. When I do this, 3's cancel on the left, and I'm left with x equals negative 24 divided by 3, which is going to be negative 8. So the solution to this system of equations is going to be the point negative 8, negative 1. Okay, I'm going to move on to number 5. Taking a look at number 5. Okay, first off, we need to pick a variable to eliminate. Okay, so nothing is going to eliminate right away, so we're going to have a little bit of scaling to do. But if I take a look at my x's right here, I've got a 4 and an 8. Okay, they both go into 8. Okay, 8 goes into 8 and 4 goes into 8. So I'm going to try to make this 4x a negative 8x. So in order to make that a negative 8x, I need to multiply the top by negative 2. So I will distribute that negative 2 to everything. I'll rewrite my equations over here. Negative 2 times 4x is going to be negative 8x. Negative 2 times negative 6y is going to be a positive 12y. And negative 2 times 12 is going to be a negative 24. And then I will rewrite my bottom equation. So I've got 8x minus 12y equals positive 24. I can combine my equations now. Negative 8x plus 8x cancels. 12y minus 12y cancels, so I'm left with a 0, or nothing on the left side. And I've got negative 24 plus 24 on the right side, which is also 0. So I've got no variable to solve for, so I can evaluate this final statement. 0 equals 0. That is true. And because it is true, I can cross out my coordinates here. My solution is going to be infinitely many solutions. Okay, so quick recap. If it's true, our final statement when we have no variables, it's going to be infinitely many. If it's false, it's going to be no solutions. On to number 6. All right, so for number 6, I have to pick a variable to eliminate, okay? Looking at 2x and negative 3x, I'm going to have to scale both equations here unless I'm going to scale by a fraction, which I try to avoid at all costs. If I take a look at my y's, I've got negative 6 and positive 12. 6 goes into 12, so that means I'm only going to have to scale the top equation here. So y is probably my best candidate here. So to make this negative 6 a negative 12, so it eliminates with this positive 12y, I need to multiply or scale my top equation by 2. So if I rewrite it over here, 2 times 2x is going to be 4x. 2 times negative 6y is going to be negative 12y. And 2 times 12 is going to be 24. And I can rewrite my bottom equation. Okay, so I can combine now. 4x minus 3x is just going to be x, or 1x. Negative 12y plus 12y will eliminate. So I have x equals 24 minus 30, which is going to be negative 6. So like usual, I can pick either the top or bottom equation, plug negative 6 in for x, and solve for y. So I am going to do the top equation. As I said earlier in the notes, it is a good exercise to try taking this negative 6 and plugging it in for both equations and seeing if you get the same answer. If you do, good chances are you've done it correctly. If you don't, you know you've done something incorrect. So if I've got my top equation here, I've got 2. Instead of x, I'm plugging in the negative 6 that I just found, minus 6y equals positive 12. 2 times negative 6 is going to be negative 12. I'll bring down everything else, the negative 6y and the positive 12. I can add 12 to both sides. Negative 12 plus 12 eliminates. So I get negative 6y equals 12 plus 12, which is 24. I can divide both sides by negative 6. When I do that, negative 6's cancel on the left. So I'm left with y equals 24 divided by negative 6, which is going to be negative 4. So these two lines are going to cross at the point negative 6, that negative a little larger, negative 4. That would be the solution to our system of equations. Okay, I know this has been a long video. We've only got 2 example problems left. Okay, so let's take a look at number 7. Okay, so taking a look at our x, we've got a negative 9 as our coefficient and a negative 5. Those aren't going to eliminate. And for our y's, we've got negative 9 and negative 6. Those are also not going to eliminate. Okay, and even a little bit more difficult for us, 5 doesn't go into 9, which means we would have to scale both of these equations. Similar for my y's, 6 doesn't go into 9, so we would have to scale both of these equations, unless we're going to scale by a fraction. Okay, so Let's find the smallest. Now let's try to eliminate x this time. So what is the smallest number that 9 and 5 both go into? Okay, I believe it is 45. So I need to make one of these positive 45y and the other negative 45y. Okay, so to make this negative 9x negative 45x, I will multiply by positive 5. And for my bottom equation, to make this negative 5x a positive 45x, I need to multiply by negative 9. So those are what I am scaling my equations by. 5 up top and negative 9 down bottom. So I know I'm going to distribute. That process doesn't change. I've just got an extra step here because I have to scale both of them. So if I do my top one first, 5 times negative 9x is going to be negative 45x. 5 times negative 9y is going to be negative 45y. So minus 45y. And 5 times 0 is going to be 0. Okay, and down bottom, negative 9 times negative 5x is going to be a positive 45x. Negative 9 times negative 6y is going to be a positive 54y. And negative 9 times positive 7 is going to be negative 63. So if I combine these, negative 45x plus 45x will eliminate. Negative 45y plus 54y is going to be a positive 9y. And 0 minus 63 is going to be negative 63. So if I divide both sides by 9, I can get the y by itself. 9's eliminate, so I get y equals negative 63 divided by 9, which is going to be negative 7. So I've solved for y. I can take this negative 7, I can plug it in for y in the top or bottom equation and solve for my x. So how about I'll do the top one again. That a little neater. For my top equation, I've got negative 9x minus 9. Instead of y, I've got negative 7 equals 0. So if I keep simplifying, I have negative 9x. Negative 9 times negative 7 is going to be a positive 63 equals 0. I can subtract 63 on both sides. When I do that, 63 minus 63 cancels, so I get negative 9x equals negative 63. I'll divide both sides by negative 9 to isolate the x. Negative 9's cancel on the left side, so I am left with x equals negative 63 divided by negative 9, which is going to be a positive 7. So the solution to this system of equations is going to be the point 7, negative 7. Okay, one more example problem left. Last one. Time flies when you're having fun. So for our top equation, we've got 3x plus 3y equals 0. For our bottom equation, we've got 10x plus 8y equals negative 16. Okay, so we have to pick a variable to eliminate. Let's try to eliminate our y. Let's eliminate y this time. So if I'm going to eliminate y, I'm going to find the smallest number that 3 and 8 both go into. And I believe the smallest number that 3 and 8 both go into is going to be 24. So I need to make one of these negative 24y and the other positive 24y. I'm going to have to scale both of them unless I want to do a fraction, which I try to avoid. So how about we make my top equation, let's get that to positive 24y. So I have to multiply plus 3y by 8. And my bottom equation, to get positive 8y to negative 24y, I have to multiply by negative 3, or scale by negative 3. So I'm going to distribute. So looking at my top equation, 8 times 3x is going to be 24x. 8 times 3y is going to be plus 24y. And 8 times 0 is going to be 0. Now for my bottom equation, negative 3 times 10x is going to be negative 30x. Negative 3 times 8y is going to be negative 24y. And negative 3 times negative 16 is going to be a positive 48. I can combine these now. If I do that, 24y minus 24y will eliminate. 24x minus 30x is going to be negative 6x. And 0 plus 48 is going to be positive 48. So to get the x by itself, I can divide both sides by negative 6. Negative 6's will cancel on the left, so I get x equals 48 divided by negative 6, which is going to be negative 8. All right, so now I need to pick the top or bottom equation and solve for my y. So how about we do let's do the bottom equation this time. So if we do the bottom equation, I'll have 10 instead of x. I've got times negative 8 plus 8y equals negative 16. 10 times negative 8 is going to be negative 80. Bring everything else down. I can add 80 on both sides. Negative 80 plus 80 eliminates. So I get 8y equals negative 16 plus 80 is going to be 64. I can divide both sides by 8. 8's eliminate on the left side, so I get y equals 64 divided by 8, which is going to be a positive 8. So these two lines, if they were to be graphed, would cross at the point negative 8, 8. Therefore, it is the solution to our system of equations. Okay? All right, and that's it for the elimination notes. Thanks for joining me today. If you have any other questions, as usual, let me know.